Today's video is an enrichment of a past presentation involving kinematics concepts such as distance, position, and displacement. How do they differ from each other? Find it out by hanging on, watch, and learn. For our first question, please refer to the positions of the three objects along the x-axis shown in the figure. We have the three objects: the dog, the tree, and the house. So the questions are, for letter A, what is the position of the dog? Letter B, what is the position of the tree? Question letter C, what is the position of the dog with respect to the house? And letter D, what is the position of the tree with respect to the dog? So for letter A, alright, so question letter A is asking for the position of the dog. Alright, all we have to do is just look at our diagram and locate where the object is, as indicated here by the positions indicated. All right, and obviously we say that the dog is located at the x coordinate equal to negative 10 meters, which means that the dog is 10 meters west of the origin. So 0 meter in the number line is usually used as the reference point. Now, for letter B, what is the position of the tree? Again, looking at the illustration or the diagram, it's obvious that the tree is located at the x coordinate equal to positive 5 meters, which means that the tree is located 5 meters east of the origin. Now, in case letter C, all right, we'll be doing some kind of uh, computation. All right, this is the what we call the formal way of getting the answer with a working or a solution. All right, so it says that uh, we are looking for the position of the dog with respect to the house. So the formula is simply delta x equal to x minus x naught. All right, where x is the location or position of the dog. All right, while x naught is the initial position referring to the position of the point of reference, which is the house. All right, so plugging in the quantities x and x naught, we have negative 10 meters, that is x, minus the value of x naught, which is positive 15. All right, so when you subtract negative 10 meters minus 15 meters, we get negative 25 meters. So that is the position of the dog with respect to the house, which means that the dog is located 25 meters west of the house. And lastly, for question letter D, using the same formula, what is the position of the tree with respect to the dog? So this time, the dog is considered as the point of reference. All right. So in substituting, x refers to the position um, of the tree. All right, which is positive 5 meters, minus the position of the dog, which is negative 10 meters. So when you subtract positive 5 meters minus negative 10 meters, the answer is positive 15 meters. All right? Meaning, the tree is 15 meters east of the dog, right? Now, what if there is no need to show the working or solution? See, for example, you're taking an exam and there are questions like this, and you want a much quicker way of determining the answer. All right, this is what we can do using the counting method. All right, let's try it in letter C. How did we get negative 25 meters? All right, since we are looking for the position of the dog with respect to the house, starting from the house, all right, you just count how far away is the dog from the house. All right, we just count in our number line. Notice that the interval is a multiple of 5 meters. So let's do the counting. All right, that's 5, 10, 15, 20, 25 meters. All right, and since our direction of counting is towards the left or westward, we indicate here, all right, the negative sign, which again means that the dog is located 25 meters west of the house. Now, similarly, for the answer in letter D, how we got positive 15 meters, this time, let's start counting from the dog, all right, in the direction eastward until the position of the tree. So let's do it. 5, 10, 15. You see, the answer is 15 meters. And since we went from left to right, therefore, the sign of that position must be positive, which means that the tree is 15 meters to the right of the dog. All right? So, the counting method is recommended if you are not required to show your working or your solution. And this is a very useful technique when you're answering questions in uh, formal exams. Our second and last question. A whale swims due east for a distance of 6.9 kilometers, turns around and goes due west for 1.8 kilometers, and finally turns around again and heads 3.7 kilometers due east. Question letter A, what is the total distance traveled by the whale? And question letter B, what are the magnitude and direction of the net displacement of the whale? So for our solution, um, we first have our vector diagram, all right? Displacement vector D1 is represented here by a red arrow directed eastward. The second displacement vector D2 represented by the blue arrow directed westward. And the third displacement vector D3 represented by the violet arrow directed eastward. Notice we displaced the three arrows a bit for clarity. And so, question letter A, what is the total distance traveled by the whale? All right, so we just add the three distances regardless of their directions. All right, as a scalar quantity, distance only refers to the magnitude of the change in position of a body without taking into account its direction. Therefore, the total distance covered by the whale is just equal to 6.9 kilometers plus 1.8 kilometers plus 3.7 kilometers, and that is delta D, or total distance traveled by the whale, is equal to 12.4 kilometers. For the last question, letter B, what are the magnitude and direction of the net displacement of the whale? So, unlike distance, displacement is a vector quantity which specifies both the magnitude and direction the body's change in position. And since we are asked to find the total displacement, use the formula d net, or total displacement, equal to displacement number 1 plus displacement number 2 plus displacement number 3. Right? We follow the sign convention, positive for displacement that is directed to the right, and negative for the displacement directed to the left. So therefore, the total displacement is equal to 6.9 kilometers. That's positive because D1 is going east. All right? Plus D2, which is negative 1.8 kilometers, since it is going west. And then plus D3, which is 3.7 kilometers. So positive because it's going east. All right? Therefore, our final answer, delta D, or the total net displacement, it is equal to 8.8 kilometers, whose direction is eastward. All right? We emphasized that the whale's net displacement is directed eastward, and that is with respect to its point of origin. In other words, in a vector diagram, the point of origin is this point here. All right? And the final, what we call position, is of course represented here by the tip of the third arrow. So that completes our video tutorial. Till our next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.